Alright, so for example number 6, we're going to focus on the law of cosines. And so the law of cosines is this: if I have a triangle, it doesn't have to be any type of triangle. This applies for any triangle where the vertices are A, B, and C, capital A, B, and C, and then the opposing sides are lowercase a, lowercase b, lowercase c, always across from the corresponding capital letter angle. Then I know that there's a relationship of a squared is equal to lowercase b squared plus lowercase c squared minus 2bc cosine of capital A. So if you have a lowercase a here, all this other stuff is the other two letters, and then you're going to take the cosine of the capital A. So if I do b squared, then this would just be a squared plus c squared minus 2a times c cosine of capital B. And then if this is c squared, then this would just be a squared plus b squared minus 2a times b cosine. If this is a lowercase c, then it'll be a capital C. Okay, so we're going to do the last three problems are law of cosines. Now, the reason you would use law of cosines in some scenarios as opposed to other ones, notice that they've given you the three sides and one angle. Okay? So three sides and one angle. So this works best in like a side angle side, but you have to have, well, you would solve for a third side. So you technically need two sides and the angle that doesn't. In other words, I got lowercase a, lowercase b, capital C, lowercase a, capital B, lowercase c. Right? So I've got two side lengths and an angle, and the angle is usually trapped between them. So this is usually used for like side angle side scenarios. Okay. So let's do example number 6. I have a triangle like this, where this is capital A, capital B, capital C. I'm told that this is 11, this is lowercase b, and this is 14. And we're asked to solve triangle A, B, C. Okay, that's what they want us to do. So I'm going to list what I know. I've got my angles here, capital A, capital B, and capital C. And then I've got my lowercase a, lowercase b, and lowercase c. So these are the sides, and these are the angles. Okay? And so what I know is that a, lowercase a, is across from capital A, so that becomes 11. Okay, so this is lowercase a, and this is lowercase c, which is 14. And I'm also given in the problem that capital B is equal to 34 degrees. And I'm not gonna I'm going to find B real quick, but I know that capital B is 34 degrees. So here I have side, the angle between them, and another side. Right? Side, angle, side. So that's a law of cosines deal. So I'm going to solve for lowercase b, so I'm going to say b squared is equal to a squared plus c squared minus 2 times a times c cosine of capital B. So b squared then is equal to 11 squared plus 14 squared minus 2 times the quantity 11 times the quantity 14 times the quantity of cosine of 34 degrees. So what I could do is I could do all this in one swoop in my calculator. So Well, I should probably just write it out because I fear that you guys will struggle with that. So this is 121. 14 times 14 is 196. And then 2 times 11 is 22. 22 times 14 is 308. So this becomes negative 308 times cosine of 34, which is 0.829. Roughly, I'm rounding at the 4th decimal place. So then when I get that, and that's all equal to b squared, then this becomes b squared is equal to 317 minus whatever this is. So this times 308 which is 255.344 if I'm rounding. So 317 minus 255 and I should get b squared is approximately 61.656, and then I got to take the square root of both sides. And I get that it's about 7.9. So B is about 7.9. And now to find the other angles, you would just use the law of sines. So I'm going to slide this up a little bit. So now to find the measure of angle A, remember I just got to say sine of capital A over lowercase a is equal to sine of capital B over lowercase b. So then that becomes sine of capital A all over A, which is 11, is equal to sine of 34 degrees all over B, which we just found to be 7.9. Okay? And so from here, I'm just going to set that aside for a second. From here, what I'm going to do is I'm going to cross multiply. This is all for sine of A, right? Or I could, let me just do this. Let's not cross multiply. Let's just figure out what this number is. So I'm going to take my calculator out, and I'm going to say sine of 34 degrees divided by 7.9. And this right here is equal to 0.708 approximately. And then this would be sine of A. Well, in the next line, I'm going to take the inverse of sine. And whatever I do on one side, I got to do on the other. Okay? And then, so that gives me, the inverse of sine cancels. That gives me A equals the inverse sine, so I'm going to hit second sine. See how that looks on the calculator? And then I'm going to plug in 0.0708. Hit enter, and it's approximately 4.1. Okay? Wait, let me double check that. So what concerns me is that this number concerns me, so maybe I made a mistake. The angle should not be 4 degrees. Alright, so I'm solving for an angle. I got 4 degrees, and so I'm going to double check my work. So let me go back here. I believe that sine of 34, whoops, is 0.559. So now I'm going to divide that by 7.9. Oh, I know what I did wrong. See this 11? We didn't do anything with that 11. So let's erase this, sorry. You got to catch yourself though. It's good that I make a mistake like you guys make a mistake. Because what helps me is what I forgot to do is I forgot to write down this 11. Okay. So then before I do that, the arc sine, what I need to do is I need to multiply this side by 11 and I need to multiply this side by 11. So the 11s will cancel. Now I've got sine of capital A is equal to this number times 11, and that's a better number. So now I got 0.77862. Now I'm going to take the arc sine, or the inverse of sine, of both sides. And then I'll explain what happened. So now when I go arc sine 0.7786, now I get 51.1 degrees. So the measure of angle A is approximately 51.1 degrees. So what I did there is a simple, honest mistake. When I went from this line to this line, I forgot about my 11. Now, algebraically, I need that 11 there because this value needs to eventually be multiplied by 11. Okay? And I just forgot to write it down. Got so excited, just forgot to write that down. So now when I multiply this value by 11, then I get sine of A is equal to 0.7786, where before we had 0.7. It's 10 times, or literally 11 times bigger. And then if you notice that my answer is almost 11 times bigger. When we did the problem before, it said 4 degrees. So when I did the problem the first time, I got an angle for measure A of 4 degrees. In other words, if we go back and we look at this image, I was saying that this was 4 degrees. It's not 4 degrees. It's 51.1 degrees. Okay? So I realized right away, hey, I made a mistake because there's no way that that's 4 degrees. Let me go back and check my work. Okay? Now to find C, I'm just going to do the same thing. I'm going to say sine of capital C over lowercase c is equal to sine of B over lowercase b. Now I did it that way because we know that sine of B over lowercase c equals this. In other words, this second term equals 0.0708, right? Sine of 34 degrees divided by 7.9 is this number. Okay? And then I'm just going to write sine of c, and then our lowercase c was given to us. It's 14. So I didn't forget this number down here this time. Again, I'm going to multiply this by 14, so it'll cancel here. Whatever I do on one side, I have to do on the other side. And I get sine of capital C is equal to these two numbers multiplied out, which is 0.0708 times 14. That is 0.9912. I'm going to take the inverse sine of both sides of the equation. And I get capital C is equal to the inverse sine of this value. which is 82.4. Again, I got another common sense check. As I add these up and I look at this 94 and 50, that's about 85. And this is 82. So let's just double check our work. I'm going to say, sine of B. So I'm going to double check our work. This should be just a tad higher. So I just want to see where I made my mistake. So 0.0708 times 14. That's right. Let me double check this again. It should be the same. Oh, yeah, let me double check. So I'm going to say sine of 34 degrees divided by 7.9. Hold on, guys. I'm just double checking all my math here. Sine of 34 over 7.9 times 14.910. Well, I think because we did some rounding, that's why we're a little bit off. So what concerns me is I've got angle A is 34, angle A is 51.1 degrees, and then angle B is 34 degrees. And if you add those up, it might not be that bad. So if you add those up, I've got 51.1 plus 34, and I got 85.5. Now if you, or 85.1, if I take 180 minus the 85.1, I get 94.9. So that's what I'm going to write down here, because that's what the textbook says. I think there's a rounding here, because the textbook said that this is 51.6. So when we rounded a little too early. So I'm going to say that this is approximately 94.9. Now what I didn't like is that this was 82.4, but when I was rounding, because this is actually, like this right here is like 0.7078 ... And I think, and when we round those numbers, it's going to vary a little bit. So I knew that this should be about 95 or close to 95. So we're not going to waste a lot of time on that. What we should have done to find C, the measure of angle C is equal to 180 minus the 34 plus 51.1, and that would be okay. That would give me the measure of angle C is equal to 94 point. 9. And the reason these are off just a little bit is because when I multiplied this number by 14, I got 99098 something something something. So this would round to 910, where before, when I rounded before, I got 912. So just do it this way. When you go to find that last angle, just add the 2 that you have up and subtract them from 180. Okay? Normally, when you do this, you go like 7 or 8. Like if you were to do this in the science, you like for a science experiment or something like that, you would round. You wouldn't even round. You'd leave the exact value, which is how the textbook did it, anyways. Okay, so we're just gonna move on to the next one. These are the answers. We're gonna do another problem, so hopefully it'll make a little more sense when we go on the second pass.